Hello, Year 7. Today we're going to be continuing on with our fractions unit by taking some time to review what we've already learnt about fractions. Here's a quick getting better at maths question for you. I'd encourage you to pause the video for a second and have a little think about it. We have this shape here, and we're being asked how many faces are exposed. And hopefully by now you've paused the video and thought about it. I think the answer is 30. Okay, so going on to our work on fractions, the first important thing we want to talk about is called equivalent fractions. These are fractions that have different numbers. So here we have 3 over 8, and over here we have 15 over 40, but they actually mean the same thing, because what we've done here in the middle, to turn our 3 over 8 into our 15 over 40, is we've times the top by 5 and we've also times the bottom by 5. And by doing that to a fraction, by timesing the top and the bottom by the same number, we actually keep its value the same. So for example, if I took 3/4 and I times the top by 3 and times the bottom by 3, I would end up with the fraction 9 over 12, and the value of both of these fractions is exactly the same. You would have seen this a little bit in the textbook questions that we were doing yesterday. We had the number line with all the dots on it that we counted, and we realized that on that number line we had 1/2 marked, but we also had all the tenths marked, and we were counting tenths. But then once we got to this fifth one, it was 1/2. But what we can do is we can take 1/2 and we can times the top by 5 and times the bottom by 5, and we can see that we end up with 5 over 10. And that's what we would expect to have found in our sequence, counting up tenths. So the other thing we need to look at today, guys, and I would like you all to write down a definition for all of these words. Proper fraction. Proper fraction is essentially a normal, if you like, fraction. It's a fraction where the number on top is smaller, than the number on the bottom. An improper fraction, though, is the opposite of that. An improper fraction is where the number on top is larger than the number on the bottom. We've seen a little bit of representing fractions on the number line already. I mentioned that question we did yesterday up here, but here is just sort of an extended representation of that, showing you the difference between fractions over 2 and fractions over 4. And this last point is also important here. We can also represent a whole number as a fraction, and we can see it here on our number line. 4 over 4 is the same as 1, or if we're counting up quarters, we have 1/4, 2/4, 3/4, 4/4. 4/4 is the same as 1. And then if we keep going, counting up to 8/4, 8 over 4 is actually the same as 2. The last thing we need to look at is writing fractions in their simplest form. So if we look back up here, we have these two fractions, 3 over 8 and 15 over 40. These both mean the same thing, but this one is the simplest form because we can't make it any smaller. And we'll show you what we do down here to make these fractions into their simplest form. If you have even numbers like this, 12 over 20, the easiest thing to do is just divide each number by 2 until you can't do it anymore. So we take half of 12, that's 6. We take half of 20, that's 10. And then we can do it one more time. Half of 6 is 3, half of 10 is 5. And that is the simplest form of this fraction. When we have odd numbers like this, it's a bit more complicated. We can't just start by dividing by 2. But what we're looking for here is we're trying to think of a number that we can use to divide 7 by and also divide 42 by. In this case, the answer is going to be 7. We're going to divide 7 by 7 and we're going to divide 42 by 7. And what we're going to end up with, 7 divided by 7 is just 1, and 42 divided by 7 is actually 6. So this is the simplest form of this fraction here, because we can't make this any smaller than it already is. And just quickly, one more thing we need to look at is how do we add and subtract fractions when they have the same denominator. This is very important, the same denominator, because if the denominators are different, our method for addition is different, and we're going to look at that in the future. Now, what we do here is when we have 3 over 10 and 4 over 10, we just add the tops together to get 7. Another way to write it would be like this. We just combine everything into one fraction, and then we add the 3 and 4 together to end up with 7. Same down the bottom here with this subtraction. We could have written it like this, and then we just do 7 minus 4, and that's how we end up with our 5 over 8. Okay, 7, here are some questions for you to get to work on. I'll be checking that these are done when I'm back.